Right. We're partially live. Let me check a few other places. Okay. It looks like we're live. Fantastic. All right. Hello, everyone, and welcome to the Golem 1.4 launch event. We expect folks to start rolling in over the next couple of minutes. So before we launch into a live demo of Golem 1.4, which of course is why you all came, we need some filler. That is, we need to just waste a few minutes of time and allow everyone to come here so they don't miss the most important part, which is going to be Offsol's demo, probably, of all the new stuff that we've added to our Rust language support. So before we get into that, I'm going to talk at a high level about some of the changes we've got in 1.4, including and most notably code first Rust agents. So we had amazing support for Rust for the longest time before we killed it completely. And that's because we pivoted away from the sort of WASM component model centric way of building, defining, and wiring together components to a so-called code first agent approach, where you actually just write ordinary code and you deploy that, and you don't have to know anything about WASM or WIT or the component model. And we did that first for TypeScript, and we launched that in Golem 1.3. And I think if you've seen Golem, you could see just how amazing that feature is to use. And we have brought it now directly to TypeScript. So now in TypeScript, we have full feature parity with the TypeScript SDK in Rust. And we've actually, I think, gone one step beyond that. In TypeScript, you just have a single notion of agent. In Rust, you have an agent definition and you have an agent implementation. And that allows you to organize code across a large application and say, okay, these implementations are going to depend on these definitions, but those are potentially going to be in separate crates. So it gives you a lot of flexibility for defining your application in a modular way. In addition, we have type-safe agent-to-agent communication in Rust, native async support, automatic schema derivation, and then, of course, full access to sort of runtime capabilities from within our Rust SDK. In addition, another major piece of work that's actually been in development, I think, for close to 6 months is a feature called atomic deployments. And this allows us to deploy basically all components of a given application together atomically in a single command. There's no partial deployments anymore. That was the problem in previous versions, but now everything is done atomically as a single transaction when you're pushing out new changes. You get instant rollbacks. You have planning and diffing, but before deploy or rollback, you can see exactly what's going to change, which is fantastic. And then as part of the process of atomic deployments, the command line interface for Golem and the manifest file have been tremendously simplified. So now we just have a very tight, small, modular, very clear and easy to use and easy to understand command tree for Golem CLI. We have multiple templates per components. We have build profiles being replaced by compositional presets for environment-specific configuration, and a variety of other things that David will talk about soon. We also have agent execution modes. Previously, we did support this notion of either a durable component or an ephemeral component, so something that's executed durably or not. But we didn't really have the ability to say, within a single component, I want this type of agent to be durable and this type of agent to be ephemeral and so forth. And those decisions ultimately need to be able to be done on a per agent type basis. And in Golem 1.4, you can do exactly that. In fact, I demoed that in my live stream last week on building NoSQL database in TypeScript. I use one ephemeral agent type and then another durable agent type. And that's very, very easy to do in Rust and TypeScript, just with little tiny annotations at the top of your agent definition or agent. Our TypeScript SDK has been, or rather our TypeScript runtime has been improved. I think we have broader Node.js library compatibility, including support for Node Stream. Other improvements, we've restored Windows support. And then also we've reactivated a whole bunch of benchmarks, and we've done a lot of performance optimization to improve performance significantly. So all this stuff has come into 1.4, and today you're going to get live demos of the key parts of this. And we're going to start with a demo of our newly introduced agent or code first agents in Rust. But before I do, I'll just turn this over to Daniel for a few minutes and ask Daniel, what are your favorite goodies coming in the 1.4 release? What gets you most excited about this release?
So originally I wanted to say that the Rust support, because obviously I was a little bit sad when we removed the support for all languages and just kept TypeScript in the previous release. But then I realized that actually our TypeScript support is quite good and enjoyable. So maybe that's not my favorite feature anymore. I would say my favorite thing is that part of this whole atomic deployment refactoring and everything that is not really visible for the users. I think we created a very good foundation for all the future developments that we are planning in the next releases, and that's my favorite part.
That's fantastic. I know as like an end user, I really appreciated the streamlining that has gone on in CLI. It's just way simpler. It's simpler and everything works. It's just really fast.
Yes.
It's color coding, where that makes sense. It's just a really nice development experience on the command line. So definitely a
Yeah,
big,
it's very, very enjoyable to use this latest version.
yeah. All right, thank you for that, Daniel. All right, I'm going to go ahead and turn this over to Afzal, who is going to show you what our newly introduced or reintroduced support for the Rust programming language looks like in Golem 1.4. Afzal?
Thank you, John. Let me share my screen first. I hope it's
Looks good.
there now. It's shared. Okay. Okay. So Golem 1.4, one of the key features in 1.4 release is Rust SDK, which allows users to develop agents in Golem using Rust language. And if you have seen the previous demo where we demoed the TypeScript SDK, you can see that this is more or less very much consistent with TypeScript SDK. If you're not familiar with TypeScript SDK, it's all good, obviously. And there are minor differences in terms of structuring the code. However, for the most part, if you are already familiar with those TypeScript SDK, as well as if you're familiar with Rust programming language, you're almost ready to go. With that out of the way, let's begin building the app. Let's bootstrap the app using Golem new. Before that, let me run the Golem server in a clean environment. And let's create a project using Golem new. And our app name is dog search. I'll explain more about that later. And it can be any name if you are just bootstrapping an app and trying it out. And select Rust default template. And I am giving a component package as dog search. Okay. Before I explain the code, let's actually deploy it so that we save some time. Dog search. Go to deploy. So while that is in progress, let's go through what's being generated here. Okay, I hope it's visible enough. All right, so in Rust SDK, we have two important annotations, macro annotations, which is the starting point for you to develop an agent in Golem. One is agent definition, the other is agent implementation. The rest is almost simple Rust as such. So here it's known as a counter agent. It's probably an oversimplified agent, but works. And this counter agent simply increments the number in a reliable, durable way. And one key thing to note here is that it has a static constructor method called as new, and it could be any name. But if you skip that, it'll throw a compilation error. So it's still building. So it throws a compilation error. And what is this constructor? This constructor takes this parameter called name, and this forms the identity of that agent, not just the name parameter, but that composed with the actual name of the agent itself, which in this case is counter agent. So this constructor parameters is an important concept when you start developing agents in Golem. And the next one is your actual agent method. And it could be anything. And in this case, it's just taking a mutable reference to self. It could be immutable as well. Anyway, that's dead simple. And then we are implementing that trait. So we are implementing this trait for counter implementation, implementing counter agent. For counter implementation, just simple implementations. New is basically constructing that counter implementation struct, and increment is basically incrementing the count. So that's it. It's a very simple agent. We will be complicating this example, or rather come up with a new example that covers most of the other features of Rust SDK. So just to repeat, with agent definition and agent implementation, you're telling Golem that this is my agent, and this is the name of the agent, this is how you construct the agent, and these are the agent methods, all discoverable. And you can add more metadata into this agent, specifically description and prompt, which can be useful in near future, especially when Golem supports MCP protocol, and the whole AI ecosystem agent build might need those prompt and descriptions. And that's very simple. You can have a higher level description of what your agent is doing, or you can have a description for each of the methods, including the constructor. So description, and you can also add a prompt, which takes a string. And likewise, you can do that for all the methods. Again, we're not going to be using any of those functionalities, or we don't need prompt and description for this demo. So let's try this counter agent before we go ahead and implement the actual document search, which I will explain later. Okay, so this is being deployed, and it's deployed. Now what we are going to do is actually interacting with that agent, which is counter agent. So Golem, using Golem REPL. And Golem REPL, if you're very new to Golem, this might be a bit of a foreign language for you. If you're familiar with Golem, you might have heard of the language RIP. So this REPL is backed by RIP language, which is going to go away soon in favor of more intuitive approach of REPL, which is actually writing Rust itself. So here it says we have a agent called as counter agent. There is a small difference in its naming. It's kebab case. Again, that's more of a specific reasoning is about the fact that RIP needs them to be like that, to put it in a very simple way. So let's construct this counter agent. You have already seen the counter agent's constructor takes a string parameter, and we give some random string parameter, which identifies this counter agent now. And then we increment numbers. And if you exit and start again, it's going to keep track of it. Doesn't lose the state of those increment, because by default, Golem is durable. So hence it's durable, and we were not using any persistent store. I keep repeating this feature whenever I demo, but I love that fact. So, and let's also look at the list of agents using Golem agent list. And here it shows the example of an agent name, which is composed of the actual agent type name, which is counter agent, and the actual parameter that you passed into the constructor, which is foo. And it's now in an idle state. Okay, so that was a super simple example, a direct explanation of whatever the template generated. So, but now let's get into something more interesting. And before that, one more thing. This agent definition and agent implementation was in one single file. And it's a matter of preference, but I think it's a good practice to not have them together. Instead, put that into a crate, which here you can see a common lib, where you just specify the agent definitions, and the implementation will be in a separate crate, such that if there is any other agent trying to depend on your agent as a remote call, they just need to only depend on a lightweight crate rather than the heavy lifting implementation crate. And here, I think we don't have the dependencies for Golem Rust. And now we should be able to import that. And I think we need to depend on common lib in your implementation crate. Let it build, and then import that. So we need this structure before we go into complicated examples. It's not super complicated what we are trying to build in this demo, but let me explain what we are going to build anyway. So going into this common crate, I'm going to put some notes here. I hope now that's big enough. Okay. So we are going to build a document search. Very simple. Every user has their own document store, essentially just adding few text data. And that itself is an agent. You should be able to add an entry, get the entry by an ID. So we should have a document ID and list all the entries. And then we should be able to search for things in the document. So we need to index the documents for easier search. And importantly, that indexing shouldn't be part of the agent, which is concerned with storing and retrieval of documents. And that gives us better orthogonal design, and not just that, it's easily scalable in that way. So basically, indexing is not co-located with the document agent and share the compute resources. And which also implies now we need an entry point. You could call it anything like an orchestrator or an ingestion agent that will add the documents, but not only adding those documents, but actually indexing them as well. And then obviously it exposes a search function that will search the index and return some matching documents. This search functionality, I'm going to build it as part of the index agent itself. It's not the ideal approach. I can explain all of that later. But once we have the fundamental things glued together, you can see where this is going and how we can expand this app and make it even more reliable and scalable. And finally, if time allows, and if things work, let's try some semantic search just to get some interesting outcome from this app. And for semantic search, the sole purpose of showing this part is to demonstrate that how easy it is to integrate things with AI providers, such that Golem is all batteries included. So how easy it is to configure certain things that now you have an AI provider and you can make use of that to make full use of AI things in your Golem agents. So once again, the agents involved, it's a document agent. It's just storing and retrieving data. Index agent, indexing the documents. And these are going to be that simple implementations as well. Search agent, I kept it as another agent, but we are going to build it as part of the index agent itself. And then finally, ingestion agent, which is the orchestrator that I talked about, basically adding the documents and indexing them. And I haven't mentioned about how we are going to build the semantic search specifically, but we will explain as we go. So let's delete this thing. Okay, Copilot is ready to complete some very valid code because I was trying this out earlier and it knows what I'm doing. We need that. So it's just a document ID, and I'm going to represent that as a number. And for much type safety, we're going to wrap that in a struct, not just for type safety, but for self-documentation. So we'll have document ID. The next thing is to define the trait document agent. Oh, it's brutal. It's expanding everything that I want, I guess. Okay. So it has 4 functionalities: add entry, take a mutable reference, which is, I think, correct because we are going to update the documentation in that agent for the doc ID, and a simple content, which is just a string, get the entry, given a document ID, get, it may or may not be present, and hence an option of string, and list all the entries, which is just a vector of document ID. But as I mentioned in the counter agent example, we need to annotate this with agent definition. Okay, now it complains. So this is the next important aspect, which we didn't see in counter agent, but now we are seeing in a compilation error here when we use document ID, that it doesn't have an instance of something called a schema, which is in Rust SDK. So any parameter which is part of those agent methods, so agent method parameters or return type or constructor parameter, those type needs to have an instance of schema, which is easily derivable through derive annotations in Rust SDK. I think we need all of that. So in save time, we keep them and then add schema as well. So schema is Golem Rust schema. So now the compilation error disappeared. Now we are good to go to the next agent, which is index agent. Before agent definition, index agent. Okay. This is for the first time. Copilot is pretty much deterministic. I think this is also a correct code. Again, new user ID. Important thing which I think I missed. A document agent is parameterized by user ID. The constructor parameter takes a user ID, which implies an agent is going to be spinned up for each user. And again, is this the right way all the time? The answer is it depends on the domain problem that you're trying to solve. In this case, we are going to assume that we just need the scalability in terms of the users. As more and more users come, I need things to be scaled up. So if a new user is coming in and adding a document, it's in the new agent. And the same for index agent as well. And here you can see it's not the famous warning of using async in trait in Rust. And the usual go-to approach for Rust devs is to use async trait, right? And we don't need to do that because it's already handled as part of agent definition. So if you are annotating your trait with agent definition, that should take care of it. So you don't need to specifically provide another async trait. In fact, if you give, I think, async trait, it's not happy. Don't use it. It's already handled. Error. So I think that covers index agent. The last one is, I think this is also correct. It's returning document ID. Okay, the last one is ingestion agent. Okay, might have completed semantic search because I documented it up here or something. We will delete that. So is this correct? I think to an extent, yes. So this is again parameterized by user ID, and then it should be able to ingest the text, and the implementation for this should be not only store the data in the documentation agent, but also to index them. And you can already imagine we are going to introduce RPC calls. So agents are communicating with each other. So it's an agent to agent communication is involved already, if you think about it. And these are async. I'm not going to, this is auto-completed as async. And I think that is true because most of this implementation involve RPC calls and calling methods, which returns future, and you need to await on that. So we don't need to change them now and then change them again. Let's save some time. All right, I think that covers the basics. Obviously, we need agent definition here. Okay, now let's go ahead and implement. We don't have counter agent anymore. We don't have any of this anymore. Okay. So just like counter agent implementation, we have ingestion agent implementation struct. It should have a user ID string and then entries, which is going to be a simple hash map of not string and string, but doc ID and string. And then implement ingestion agent, not ingestion agent. Sorry, it's not ingestion agent, document store agent. Document store agent implementation, and implement document store. Okay, it's document agent. It's document agent implementation. Implement documentation agent for document agent implementation. Oh, nice. Is that correct? I think yes. So constructor is basically forming document agent implementation with user ID with a default value of entries, which is an empty hash map. And adding an entry is given a document ID and some content. It's inserting into the hash map, and get entry is just getting it, and it's going to be optional value. And then listing all the entries is listing just the document IDs. That simple. And none of this is async. It doesn't need to be. And okay, you might have some questions around like what's the size of this document. Again, that discussion can go on forever. You can partition things in this app at several layers. You can partition the users, you can co-locate all the documents in one agent, you can partition the document itself. But for now, let's begin with just hash map of document ID and string, and assume that the user is not going to give a terabyte of data into this agent. What's next? The next is index agent implementation. Oh, that's interesting. That's correct. User ID, obviously. And then we are going to use an inverted index. Just a simple indexing that this string is essentially representing the token itself and not the actual content. We could make it more type safe later. And then the list of document IDs that has those documents that consist of the token. And we are going to build that inverted index as part of index agent implementation. Implement index agent or index agent implementation. Oh, wow. Okay. This is making things far easy for me. Okay, so the constructor is again simple, default hash map. And here is the interesting part. Whenever we annotated your trait with agent definition, it generates a client, and that is an RPC client. And the name of that client is document agent client. Anything after the, agent type name suffixed with just client. And that has the exact functionalities in that agent, just that you're going to do an RPC call. So here it's document agent client, which is generated. You can import that. And this client has a function called as get. Let's try and do this manually. So it has a function called as get, and it takes exactly user ID because the constructor parameter in the document agent was taking user ID. So get user ID. You pass the same user ID in the struct, which you constructed. And then store.getEntry is going to return a future. And hence we need to await for it, which returns a content, may or may not return a content. So if there is a content existing, I think this is correct. Lowercase, yeah, I think that is correct. Okay, so it's just pushing that token into the inverted index and the token is basically splitting the white space and then pushing the doc ID, which is corresponding doc ID, into the inverted index hash map. And hence search is really simple as well. Getting it from the inverted index for the term that you're searching for, and then unwrap or default. Yeah, I think that is correct. So super simple implementations for an indexing of documents. All right, I think that's done. We need to annotate that with agent implementation. So what happens if you forget to annotate that with agent implementation? Basically, at that point, it doesn't register index agent at all because it doesn't know what to do with it. You're just only having agent definition. There is no actual implementation, which essentially means you can't know how to interact with it. So you need to specify agent implementation here and thereby have successful registration of these agents and Golem runtime be aware of these agents. The last one is let's make some space. Last one is, it doesn't need to be public. I don't know why I'm doing that. Anyway, what is the last one? Ingestion agent implementation. Right, it's also parameterized by user ID, and it's just doc ID itself. We are going to have an incrementing document ID, and since Golem is durable, you can just keep incrementing just like what we did in counter agent. You can also use an UUID instead of that and make this ingestion agent far more simpler, but let's keep this for now. Agent implementation, implement ingestion agent for ingestion agent implementation. Hate this. Okay. So we are going to implement these three. This is going to be simple. So what to do in ingest agent? We already seen an example of RPC call. It's type safe. We need the same here in ingest test. For what? One, to store the document into the document agent and then index that document using the index agent. It's interrupting too much, but it's saving some time, so I'm okay. I mean, Copilot. Okay, let's create some helpers here just to keep things a little bit cleaner. Okay. So, so we are going to use the doc ID form, and then add entry needs a mutable reference to store, and then store add entry, document, and content. We'll do that. That's the last step. So that the next call will be using the next incremented document ID. As you can see, the next bit is you're ingesting the data. For that, you need an indexing the data. So you need an index agent client, and then index the entry. This is not ideal, by the way, because every time you ingest the data, it's not only spending time storing, it's also spending time indexing it. We will fix that later. Search is okay. So is this correct? So index agent is, so since our search is within the index agent, which is a little weird, but we will keep it for now. So index agent client, and using that search the term, it returns a vector of document IDs. And then you're using the actual document store to retrieve the data corresponding to that document ID. I think this implementation is correct as well. So we are done here. So we are almost done with reasonably working document search. But let's try and deploy this and interact with it. I'm just trying to think if there is anything that I missed out. Okay, looks good. So I'm going to reset everything just to have a very clean environment. And okay, so this gives an error. Why? So if for those who are familiar with Golem before, we expose HTTP APIs for all these agents. So when you created the project, bootstrap the project from the beginning, it has the setup to expose all of your agent methods as an HTTP REST API. And that exists in Golem YAML. And this is just an API definition. And I'm not going to explain each part of it, and we are also not going to use it. But here you can see it expose certain HTTP paths and then do some response mapping using rib itself, which is the same language that we use in REPL, and then respond with an HTTP response, status code, and body. Here it was counter agent and incrementing, which is not the case anymore, and that's why it was failing. And probably you will have the same experience when trying things for the first time and changing things. So for now, let's comment them out and deploy it again. Oh, I used reset. Okay, let's wait for a couple of seconds. Again, interacting with this agent using REPL. Now you can see the new set of exports. So you have an ingestion agent and its constructor parameter is string. It has got two functions, I think two functions in it: ingest and search, an index agent, and document agent. But we don't really, as a user, we are not going to directly interact with these internal agents. We are going to interact with only ingestion agent. And these are auto-completed. So ingestion agent, auto-complete with foo. Ingestion agent takes a user ID as constructor parameter. So let's give a reasonable user ID, which is my own name. And, okay, that's one. So, and let's ingest some data. Foobar. Bars. And let's try searching. Should work. So foo should come once, and bar should come twice, and bar should come once. So yes, bar existing to content, and then exciting. That was simple. But let's go back. And before I explain the problems in this agent, and we are not going to fix all of them, but I will be explaining some of these problems and how we can improve it. But before we do that, let's make this search a little bit more interesting, which shows how you can integrate this app with the batteries included Golem AI. Okay, so just to repeat, what are we trying to build? We are going to build a semantic search. So it's not exact keyword search. And we are not going to use any GPT-4 LLM models with hallucinating results, or maybe slightly non-deterministic results, or maybe I'm wrong because it might be using embedders inside. Anyway, we are not using LLM models. Instead, we are using embedding models, embedders. And there are various providers for this embedding. OpenAI is an example itself. Another one is what was that name called? I forgot all of that. Cohere AI is another example. We are going to use Cohere AI. Yeah, this is the important point. OpenAI doesn't support semantic search, but Cohere AI does. So we will be using Cohere AI, and to have a user account in Cohere AI, it's simple. You add a token so that now you can interact, use the Cohere AI models. And Golem AI is something that you can enable in your app by going into Cargo Toml. The Golem Rust has integration with Golem AI, just that it is under a feature flag, Golem AI. So now you can make use of this APIs in Golem AI, which is mostly a unified API. Regardless of the providers you use, it has the same API. It has varying runtime semantics, but at that point, it is your responsibility to make sure that you're using this API correctly and enabling the provider correctly. I will show you both. The first thing to do is to enable Golem AI, and then go back to our agent definitions. We will be adding it as part of index agent itself for now. Semantic search. Okay, so semantic search, it's not a simple search, but a semantic search. And it's going to give you a vector of document ID. I don't think that we need a vector of document ID. Instead, we just need the final string that matches. You can also give a vector of string or vector of document IDs, which will be ranking the similarities. But for now, we will ignore if it is empty, and we will ignore the rest of the documents which matches. We'll just pick only the very first one. And if that also doesn't exist, it's a none. And then we go to document search, implementations. Now, as you can see, it complains for it. Semantic search. So first thing, let's import Golem AI things. So Golem REST, Golem AI, Golem. There are various packages. We are concerned with embed. And we need re-rank functionalities. So for those who are completely new to embedding, it's mapping your content image or text or whatever to a vector space of numbers, basically an n-dimensional vector space. And instead of we hand coding all of this stuff using cosine similarity and redoing it, let's use a proper model which was trained with Incohere and and I hope that it gives a deterministic result all the time. So re-rank is required, and config and task type. So semantic search is going to be, I think it's doing long. It's not that confident about that much. Okay, let's build a config, which is the embed config. Obviously, I have tried this before, and the model that I used is re-rank v3.5. And you need to provide a task type, because with task type, you can, as you can see, there are various task type, and the one that we are interested in is semantic similarity. And then let's see what is re-rank doing. Re-rank will query. We'll take 3 parameters. One is the actual query, and the next is the document, so it re-ranks it, and then the actual config. What is the result here? Oh, it's a result. So for now, let's unwrap this. We will quickly fix that. It's not good. And then the documents is empty, which is not good. So let's connect to the document agent, get all the documents, and retrieve all the documents. Use that instead. And then re-rank response will give you the index of the document, which it thinks that it's semantically closer. So result.results, we care about only the first one, and then map the re-rank result with documents. Yeah, I think maybe that's not correct. Use size. So it gives the index of the document, which it's semantically matched, and we retrieve the actual document by doing documents of index. Fairly simple enough. I think we implemented semantic search to some extent. This doesn't need to be mutable. Okay, but this is within index agent. We need to expose this functionality in the orchestrator so that we can call it from outside. You can obviously call it directly to the index agent, but let's make this proper. I think that's also wrong. And also we haven't added this document, sorry, semantic search within the index agent. Again, it's an option of string. But when we do this, let's fix this return type to be a good one using result. Because we did an unwrap. Cool. That'll be the same here. And let's go here and just simply delegate it back to index agent client. We need the index agent client and index.semantic search and query. And the result type is option of string. I think we are done here. But we missed one important step. Okay, this is now unhappy because we changed it to result. And here it's not that. Okay, it's not, the error type is not string, so let's convert it to string. And this is okay of final response. Is there anything critically missing here? So what happens if the document is empty? Think, yeah, I think that's correct. Okay, so now we missed one important part. We use the Golem AI APIs, but we haven't specified any providers in anywhere. So which provider does it use? We don't know. So the way to do that is going to Golem YAML. You can see various providers in here specified. So let's search for embed. So here is the embedding providers. You have OpenAI. This is the stuff that I forgot. Hugging Face is another AI provider, embedding provider that actually supports semantic search. So if things are not working with Cohere, maybe you can try Hugging Face. Voyage AI doesn't work with semantic search as far as I know. Let's enable Cohere. And there is one more thing which you need to be aware of, which is the environment parameters that is required to interact with these providers. Obviously, if you forgot to do that, you will get a runtime error saying that this environment variable is not there, and you can obviously come here and fix it. And once you're familiar with these two aspects, I think it's very simple. So environment variable, set that, and then specify the right dependency. I'm not going to explain what exactly is this dependency. It's a awesome file. For now, all that you need to be aware is that uncomment the dependency under the provider name. And the key here is wrong. So I might be sharing this key in this demo. I don't think it's a big problem. It's a trial key anyway. Hopefully that works. So you can always create a trial key. Hopefully it's not expired or anything. And coming here, dating it. Now I think we are done. Let's see if this thing works. Golem deploy. Let's see if everything is in place. It's a semantic search and its implementation thing. I think this should get us going. It's taking a bit of time. Not sure why. Okay, Golem. Is semantic search in place? Yes, it is in place. So let's add some data. Same up. So let's search for something. It should give an empty list, of course. Let's ingest some data. Same thing. Foo bar. And then let's see if search works. Yeah, it works as before. Well, let's add some interesting data. So let's say Golem helps developing durable agents. Now, obviously, if you search for something like reliable applications, none of those tokens exist anywhere. It's going to give an empty list. But what happens if you do semantic search? I hope it works. Reliable applications. So again, reliable or applications is not part of any of those tokens. So let's see if this model works. And it does. So even if it doesn't match exactly, it's giving out a proper result. So Golem, it identified that Golem is reliable. Maybe let's do a semantic search on oops. Yeah, it picked up foobar. And if we do a foo, yeah, it returns. So that is also working. Okay, so now let's get back to a few important aspects. Okay, semantic search works. Most importantly, you know how to integrate your Golem provider in your Golem agents in Rust SDK, in Rust agents. The most important thing that I wanted to point out here is ingest text. We are going back to our fundamental use case, which is just ingesting and indexing. Indexing is part of ingesting, which is not great because you don't need to wait for it. For that, you can use a fire and forget strategy. So every agent method has the original agent method. Along with that, you have two more variants of it. One is trigger and schedule. So if you call trigger and underscore the same agent method name, which is all auto-completed, it's all part of the client, it just, you don't need to await for it because it doesn't return a future. It's basically firing and forgetting about it. You send a message that it should be done, and it should be done in the background. So this makes your first level of optimization done. I'm not going to rerun this again and again. So that's one thing. The second thing is, I think I've already mentioned it. User ID was one way to scale your app, but that's not always the case. Sometimes you might have millions of users and you might need to shard these user IDs. And sometimes you also need to partition the documents itself. So we are not going to build all of that, but you can certainly take this app, which I built, and expand on top of it and try and implement more complicated use cases, which will give you a good familiarity with some of the internals and limitations of Golem. But for the most part, you should be able to do everything because the runtime APIs, which is available through Golem Rust SDK, helps you do most of the advanced stuff. Another aspect which I didn't mention here is, what if you don't have a proper domain key to represent your agent identity? So for example, you don't have a user ID. Let's go back to ingestion agent. Let's say you don't have a user ID, but every ingestion should still be happening in a new agent. So when you don't have a constructor parameter at all, it becomes a singleton agent in the cluster. There is only one instance of that agent at any point. And yet, if you want to make sure that you don't have a constructor parameter or anything, and at the same time you need to keep creating new agents, you can use a functionality called as new fandom, which is a function instead of get. And this will ensure that it's always in a new agent. Another aspect is, I think, which is important is, let's say your document ID was just a UUID. So at that point, document ID doesn't exist here. You don't need to keep a state of it. So there is no more state involved in ingestion agent at all. So you don't really need that to be durable. So by default, every agents are durable. But you can configure whether your agent needs to be durable or not by just simply providing a mode and make it ephemeral. Remember that if you make this ephemeral and you're still going ahead with the strategy of this incrementing document ID, it won't work. It'll be always 0. I haven't tried, but I'm pretty sure it'll be always 0 because it's just ephemeral. It's not durable. You're not keeping the state. Right. And then there are other aspects which you should be aware of. I think one thing is Golem agents essentially is single-threaded. We've already seen some async functionalities being used here. So within an agent method, if you have a network call or a file system call or other IO, it will interleave, obviously. But at one point, one agent method will be working. When you invoke from outside, for example, so there is a clear boundary that only one agent method will be running at a point. So there are two agent methods will not interleave. So it's not multi-threaded, but that doesn't mean you cannot parallelize things. So when you system design your app with Golem, you can structure your agents in a way that you can introduce parallelism. So for example, you can segregate certain functionalities from one agent to another one. For example, here I have search within indexing, but search is not really doing anything with the state, I guess. So you can push that into a separate search agent, and you can actually make it as an ephemeral agent. And that's not a clear example of parallelism, but what I meant to say is that you can structure your agents in a way that you can bring in parallelism. And I don't think there is any blocker on top of blocker just because agent by itself is a single-threaded app. So these things need to be considered when you design the app. And then there are some really interesting runtime APIs, not just interesting, but highly useful runtime APIs, such as fork and Golem promises, which is just a cluster-wide promise ID. So one agent can create this promise and the other agent can actually wait for that promise to complete. And there are so many advanced things in the Golem Rust, not Golem Rust, the runtime APIs. And these are not built as part of 1.4. This was already built before. But now Rust SDK is just that unified SDK, through which you can do all of that or use all of those runtime API methods, as well as I demonstrated, the Golem AI as well. I think that is reasonably enough for you to get going with building an agent using Golem in Rust. I hope that was useful. With that, I will leave it to you, David.
Thank you, Afsa. Let me also share my screen. Hopefully it's working now. So I'm going to talk about the other bigger topic which John mentioned in the introduction, which is atomic, and also internally we call this atomic and immutable deployments, and how these are changing compared to our previous solutions. In some sense, I would say that atomic deployment is mostly about reaching to a similar developer experience what we achieve with the code-first approach for programming. We also want something which is also pretty much easy, self-evident, and working quickly for managing your infra setups, including local and custom and or cloud solutions as well. If I prepared already a project, I will not going to do the whole create new applications because I will mostly concentrate on how the manifest changed and how does deploying and reverting looks like. But even before that, I want to mention for those who were not using previous Golem versions that before that, for all the different entities which are making up our infrastructure, including components, which are the containers for agent, and HTTP API definitions and deployments. All of these had their own incremental APIs, which were used to create them, update them, delete them, and so on. And that kind of works, and we also try to hide this complexity even before versions in the CLI. But that also meant that there were no easy way to make a proper different diffing between what I have currently locally or what I have in cloud. And for example, this made it very hard to decide on deleting any kind of entities automatically or detecting what is not used anymore. Also related to this, in previous versions, we had projects, but they were optional, and that was also kind of created some boundaries for detecting such changes, but it was not always mandatory, and it was kind of not uniform across all. And with atomic deployment, now we are saying that if you create an application using the application manifest, that is going to be one unit of deployment. It will be always handled together, regardless whether you are using localhost, whether you are using Golem Cloud. Applications are already a closed unit, and this means that from now on, the app property in the manifest is mandatory. You will always have to define a name. And as you see, you can also define application environments, which will and can target different installations of the Golem server. By default, in Ambly template, we include a local one, which you can see uses or local server, which is what you get when you use Golem server run. And also we have by default the cloud, which of course targets or custom hosted solution called Golem Cloud. And if I would like to have something, for example, I could have, even in cloud, I could have, let's say, a pre-prod environment. Or let's say I want to use a custom Docker or any other installation of Golem for, let's say, integration testing purposes. I can define my custom server either still targeting cloud and using a different environment name, or I can even customize my server URL. Let me show you a small picture from our documentation, how this behaves and looks like. So as you can see in this manifest example, I have a local and the cloud environment as before, but I also have one for, as I just started to write, an integ one using my custom server, and I have a pre-prod one using cloud. But how this maps to actual installs, and we will see. And we use the Golem deploy command. By default, if we use the local environment, but we can customize that what is the default one. But most probably we will use the environment command line flag and choose one of the defined environments. And you can see that depending on these flag, that actually identifies the server I want to target, and inside of that, the application I want to target, and inside of that, the specific environment. So for example, in these examples, I only have one application and one environment, but even locally now, which is something we couldn't provide before atomic deployments, locally, you can now have several projects working on all of them in nicely separated parts. And for example, in Golem Cloud, you can easily have as many environments as you need for different purposes, like as this in this example, using a prepared environment. So let's go back to our manifest file and see what does it mean in general for the CLI. So as I said before, we had a lot of commands like Golem component, update, delete, new, create. All of this is gone. We do not need this anymore. The only command you should remember is Golem deploy. And you can also notice that now that finally we reached this state where everything is orchestrated by these application boundaries, we felt like there is no more need to use this up subcommand anymore. So we can just simply say Golem deploy. And what will happen, I already have in the background running my server. You can see that, as usually, it triggers build depending on up-to-date checks. I already built it, so that doesn't happen. And similarly, what we had in 1.3 and before, we have divs. But what's interesting, now we have one unified div because the whole infrastructure is having one div. As you can see, I will create components, HTTP IP definitions, and we have also one more separated div, which is interesting mostly from the agent point of view. Here we will see if there are interface changes in our agent. So we can easily spot if there is a new method, if there is a remove method. And I will show you this quickly. And after that, we can also see that we will get a detailed plan, what will exactly happen. If we say yes, so again, we can see it in the div as well, but it will create based on this default template, my component, my HTTP definition, my HTTP deployment. So let's continue. And another thing I would like to highlight and will show you that previously it was also very, very tricky to use multiple apps, as I said, especially for bindings. But now with this new approach, now we have an identity of the application. So by default, all templates will use your app name.localhost during the bindings. And this means I can easily develop locally even multiple applications without restarting my server and just running one server at a time. Okay, let's do the deployment. And we can see it was created. So far, so good. One thing I want to also briefly mention for people who are using Golem before, that we still have profiles, and in the documentation on learn.golem.com, cloud, sorry, we explain it that. So most of the time you want to work with an application manifest, but of course there are reasons like when you are in a DevOps role to just interact and list all the available application environments. For these cases, we still offer and provide profiles. And this means that even without an application manifest, you can specify a profile, for example, and we include those also for the built-in local and cloud environment. So you can connect to the cloud and select explicitly via the environment flag an environment, and you can list the components there and so on. So profiles are there, but their use cases are now limited to DevOps purposes. For all the other times, you should be focused on defining all your servers and all your properties in environments. So for this demo, what I would like to do is very quickly, I will just, to make it simpler, I will create this inc1 method. Let's deploy again. And as you can see, the metadata changed for the component because the compiled version binary changed. And also we can get a nice little div that, hey, the control agent lost its increment method and now it has something called inc1. Let's deploy it again. And the same error which was Afsal describing, because there is no more increment method, I cannot bind this. And for this demo, I will also disable the HTTP APIs and deployments. And that can also will show us a nice example of how does it look like when I'm removing stuff from my application. Now we can see that, oppa, so we are not having any more the HTTP definitions, the deployments, but there are still changes in the bosom, and we have our new method. So we get a nice plan of what will happen to my environment. Let's go forward. All right, and just to briefly mention why we are seeing two diffs. So in the background, because we cannot and should not lock the whole environment, in the background we are still doing small incremental changes to a new thing called a staging area. And if there is some concurrent error, for example, other user deploying or CI going rogue, then it will detect that there was some concurrent deployment happening. Or another case when this can happen, when then some final validation, like the affirm mentioned HTTP rib error happens, then we still have the stage changes, and we only have to apply a few more. But still in these cases, we will get a full plan and a full diff to what is the difference between my local repository and between the target. But sometimes I will get a middle diff for what is still needs to be staged before deployment. So this deployment happened, and we can see we have a new deployment revision 1. Let's do a few more changes. Just for fun, I will add inc2 with pretty exciting implementation, and inc3. Oh, sorry, just inc1. I will also add a function called hello, which will just return a string, and it will return for now, just let's say saying 1. And oh, because it's async, let's make it simple. Okay, let's deploy again. So remember, this was revision 1. Now we're going to create revision 2. And you can see we added inc2, we added hello. We will update the component binary. Let's go. We have a new deployment revision. And as a final change, we will also add inc3, which increment by 3. And we will change this hello to return to. So let's deploy. We can see we have a new function, the method in this agent. Let's deploy again. So far so good. And if I were to invoke this agent, let's say counter agent and I will call hello on it, we will see that this returns 2. But what if I made a mistake and I quickly want to revert? Well, Golem deployed now, although the same command can be used to revert. But instead of creating a new deployment from scratch based on my local environment, I will just use the revision flag. And let's see what happens if I want to go back to version 0 or revision 0. But for now, let's just plan. Sorry, this is not true, but we will just cancel it. I will fix this. Think it will be soon available with plan flag 2. So let's have the version 0 or revision 1, sorry. So we can see that if we were going back to the first revision, all of these would be gone. But let's cancel here. If we would go back to revision 2, only the lastly added inc2 would be gone. So let's go back. And as I showed you before, with invoking currently returns 2, let's revert to this version 1. Or let me see what it will do. Sorry, revision. The other one, which still has hello. And also we will use the old flag reset, which will also drop our agents as well. Let's do so. It also asks me do I really want to drop all my agents? Let's do that as well. And now if I invoke, it will return 1, even though currently my code is saying 2. I was very easily able to quickly revert everything. And depending on what I want to do with my durable agents, maybe I want to reset them, maybe I want to update them. Depending on the use case, I can use different flags to do so. Another thing which I would like to highlight with this release is that we also made it a bit more streamlined how one can define component properties. One of them is Afzal showed us that so many times we would like to define environment variables for the component or dependencies. And previously, these dependencies were part of the YAML, but were in a separate place. Now we unified that, and it's simply part of the same component spec part. But what we also changed now is that it's very easy now to use component templates. So originally these were created for abstracting away how different languages are built, but now they can be used for any kind of reasons when you want to customize based on, let's say, debug or release flags, or you want to extract some common properties. For example, I could say component template, and I can say I will define a template called commonenv, and I can say that in debug, which usually not that interesting for TypeScript, but let's say we are using Rust. For debug, I can customize the envars, and I could say that the log will be debug, again, depending on what kind of library you use for logging. Or you can say that in release, maybe it's Rust log, I believe, or I don't know which way we are using, but you can imagine these use cases. And previously, this was impossible. Only one template was applied or was able to be applied. And now I can just say common out, and this will be also substituted in the order how I define these templates. And another seeing that even as Afsa was demoing, it happens frequently that, let's say, when I'm developing locally, I might use the Golem AI LLM library, but locally, I'm okay with using a small model just for having some kind of loops and just trying out some features. And let's say I just want to use Olama. But when I'm going to production, let's say I want to use OpenAI. To able to customize such things, we can also use presets, and there are special presets for this. When I use the append prefix for a preset name, and I say local, which are matching the environment name in my root Golem YAML, I can add dependencies which are only applied when, and again, so AI just created some URL, but let's say, yeah, it's OpenAI, or I want Olama. Again, the actual URL is not the point here now, but the point is that I can also define append cloud, and for that, I could use OpenAI. So there are even more features in these cascading solution, which I'm not going to show you, but the intention is that if you need any kind of customization or extracting configuration, or intention is that you never have to leave Golem as a tool, and you never have to generate Golem YAMLs, or you never have to use another tool just on top of Golem. Hopefully, you can see that this is quite configurable for many use cases. And just to relate it to that, let me show you also one of the new commands, which is Golem component manifest trace, which I probably made a mistake in the component templates part. And yes, sorry, so this needs the presets. So templates can contain, of course, in the root part, for example, environment settings, but also by presets. Let's retry again. And another one is Rust log, yes. So how do we define, sorry, environments? Yes, this part I missed. And you can see everything is validated. So it's good that it failed, because I did not make a silly mistake in my YAML. So everything is fully validated. And now, what you can see here is basically an X-ray of how these separate layers are applied. So in this component, I have the TS layer, which is defined by Golem itself in these common directories, which defines how can I build this component. And then I have the common env. Then I have the selection of common env debug because I was using the default local environment. And if we go back to the Golem YAML, we can see that by default, the local environment will picks the debug preset. And it will also use the component parts, and it will pick the append local parts, which means if I check, for example, the dependencies, let's just quickly search for that. We can see that the final value is currently Olama. Let's see what happens if I change the environment to cloud. And also, let's change the preset. And I do not have to change the preset because that will implicitly use the release preset. And now if we search for the dependency, we can see it's now OpenAI. And again, if there are multiple layers affecting this value, I could get a nice log of which layer did what with this value. And just to quickly mention again, now one of the biggest changes for the HTTP API deployment is now our templates will use these application name prefixes for deployment, which is pretty nice because if you are calling it from a browser, it will automatically work. And if you are using some custom clients, you can always target localhost and use a host header containing the full application name, making it very easy again to deploy concurrently with the same server multiple applications. And of course, all of our deployments should still work with Golem Cloud. And I'm asking if Andrew, are you here? Let's
Yep,
wait
I'm
a
here.
minute. Yeah, then I'm giving you the sharing.
Great. Okay. So yeah, I'll do a demo of the latest console. Let me share tab. Okay, you should be able to see my screen now. Does that look good, everyone?
Can you maybe make it a little bit bigger?
Yeah.
Thank you.
That better?
Yes.
Sweet. Okay. Yeah, we've made some changes to the console since the last release. Primarily, I think you're going to notice that it's application oriented at the top level. We also have a few new views and fully support the new agent orientation as well. So I'll go over a quick demo of some of the views, but for the most part, it should all look pretty familiar and behave exactly as previously. So right off the bat, you can see applications are listed here. This view all button will take you to a view that actually dedicated to listing applications, and you can view those in card or list form. You can also create a new application with this new application format. It's pretty simple, but just the one input, but that would allow you to create a new application here on the front end. Likewise, if you click that, sorry, that was probably too quick. If you click this environments button, it'll show you all environments that you have access to. So this could be environments that are shared to you or environments that you've created inside some of your applications. I say inside, that's not really the structure of it, but for the most part, you could think of it like that. I don't have any shared environments, but I have created some. But if I did, they would be listed here. So let me go ahead and click into the example one application here. So this is the application details page. You can see its ID, current revision, account ID of the owner, as well as a list of the environments. And you can also create new environments from this page by clicking that new button and filling out this form. So now you can see I have an example 2 environment here. I'm going to go ahead and click Cloud Dev Environment. So this is the environment details page. You can see the current deployment is the first deployment. We have one deployment. Number 0 is the first one. No domains configured on this. If you go to Deployments tab up here, you can see all the deployments. So far, I've only made one deployment. This APIs page will show you your definitions and API deployments, which I don't have any of, but you can see I have one route available here. Domains is coming soon under development, and these settings just allow you to see environment information and update these permissions related to the environment. But currently I haven't done any sharing or anything that requires permissions. So to actually check out the component and agents, agent types and agents, you have to click this runtime. This will allow you to select a deployment to be looking at. I only have one, so select the first one and you can see basic information about the deployment here. related to how many agent types there are and how many deployed components there are. You can see I have this example one, package one component. This was written and created using the CLI that was just demonstrated. And you can see this is the basic counter agent example. You can see all of your agent types here. You can see where it was implemented by. And running agents, you can actually see on this view. You can also create new agents here. So I'll go ahead and click create agent to create one. Select your component and agent type, and then give this a name because it expects one argument here. So just give this a name. Live demo one. Okay, create that agent. All right, you should be redirected after successfully creating an agent to the agent details page, which is this one. On the front page, again, this is all like existing stuff that was there previously. Most of this from the last release, but for this release, it's all application, environment, and agent oriented. But you can see status, memory usage, this page. Live invocations, there's only been one, and it's a call to this initialize function. And if there were any live messages coming out of our agent, you would see them here in this live terminal. Likewise, if you go to this live panel, you can see the same view here, live terminal output, the invocations that have been made so far. And this would be application logs, things that like come out of console.log. We can view environment here. No environment variables set because I didn't set any when I made this. You can also invoke this agent. Looks like I forgot to select a. It was saying I forgot to select an environment, but it actually, I guess that would be like a business logic issue since it wasn't created at that time. But anyways, you can invoke agents from here. So this is already pre-selected, but if I had more than one agent type or more than one method, you could select a different one here. And you can invoke this increment function from the front end. So go ahead and click invoke. And you can see the result here. It's value 1. So if we invoke a couple more times, you'll see that value going up. All right, yep. So let's see. We have access to see the files that are uploaded and manage the agent itself. You can interrupt and resume an agent or delete an agent from here. We also have agent recovery for agents that run into an issue that's not automatically recoverable. You can recover your agent from this page by viewing the calls that have been made, the external API calls, I believe. And you can see the details here. These are some of the increment calls that I made. So this is the last one here. int5 was the last result. You can click on this region link to expand what you're seeing there. Likewise, we have a debugger for your agents. So I'm looking at the agent right now. I can set debugger breakpoints such as on this one, which, let's see, that was 1, 2. I believe that was the second. So setting a breakpoint there, if I go ahead and play back, it starts reconnecting, apparently. Oh, this is because I'm running this locally. There's an issue there, but we can just go ahead and use the agent recovery and roll back to before the third one. There we go. So agent has been rewound. Now if we go invoke again, we should see, yep, we're now back at 4. Go to 5, 6. Okay, back to 8. Recovery, you can see, has added new entry points. So if we go back to before this one, go back to invoke, and you'll see the state of our agent is back down to 6 because I pressed this multiple times. You can also invoke from the debugger page as well. And this shows the stateful nature of some agents. But that's pretty much everything I have to show you guys in the new console. Yep, for the most part, this is as it was previously, now focused on applications, environments, and agents. So that's all I have to share. Thanks. And I guess I'll be turning it back over to maybe Daniel, John.
Yes, thank you so much for that demo. Thank you for the demo, Afzal and David and Andrew. Fantastic work. So in conclusion, I think you can see 1.4 may not be a big release. It's coming right on the heels of the 1.3 release, but it contains a lot of new great functionality, including Rust support for our code-first agents, as well as the new atomic deployments and greatly streamlined CLI experience. And then, of course, an updated and agent-focused console for those of you who are playing around with our sort of managed version of Golem Cloud. So I hope you have enjoyed these changes and are looking forward as much as I am to Golem 1.5. We got a bunch of new stuff in there planned for you, including simplification of the way you interact with agents. You're no longer going to have to use a REPL that has rib in it. You're going to be able to use a TypeScript specific REPL if you're building TypeScript agents, or a Rust specific REPL if you're building Rust agents, etc. So it's going to be a language native REPL experience to allow you to interact with your agents. And we've got lots of features coming to make all of Golem more agent native. Snapshots, for example, which allows us to do instantaneous recovery after downtimes or resuspension of agents that were previously suspended for scheduling reasons, and lots of other great stuff coming down the pipeline. So please stay tuned for upcoming events. We're going to do a lot more of these live streams, building cool stuff on top of Golem in Rust and TypeScript now, 2 languages to choose from. And we hope to see you there. Don't forget to join our Discord right up there, courtesy of a bit.ly link, bit.ly/Golem Cloud Discord, where you can find the Golem contributors discussing and helping both people as well as AI bots through the challenges involved in interacting with Golem. Hope to see you there and at future Golem events. I'll see you all